So in this lesson, our topic is about vectors. So a vector can be represented as a directed line segment. So a directed line segment means a line with a known direction. The direction of the line is usually the direction of the vector, and the length of that line is the magnitude of the vector. And if I want to represent a vector describing the displacement of B from A, we usually write it as a B in bold. So if I'm given 2 points, so the first point is A and the second point is B. Now this is a directed line segment because this is a line with a known direction. So you can see here the arrow represents the direction. Now my vector, which is A, is going from point A to point B with this direction as shown in the arrow. Now if I'm given 2 vectors, I can say that these vectors are equal if and only if they have the same magnitude and the same direction. So there are 2 conditions that should be met. So the first one is that both vectors should be equal in magnitude and both of them should follow the same direction. So if I'm given 2 vectors, vector AB and vector CD. Now these vectors are equal because they are following the same direction as shown in the arrow, and the length of AB is equal to the length of CD, so their magnitudes are equal. So both vectors, vector AB and vector CD, are equal. Now I say that 2 vectors are parallel if and only if they have the same direction. So here the magnitude is irrelevant. So what I care about is only the direction. So vector U and vector V, they are following the same direction. So vector U and vector V are parallel. Now if I want to add or subtract vectors, I have to use the triangle law of addition. So vector AC is equal to vector AB plus vector BC. So to go from point A to point C, I have first to go from A to B, so AB, then I have to go from B to C, so BC. So vector AC is equal to the addition of vector AB and vector BC. In this example, I'm given a triangle OAB. M is the midpoint of OA, and N, this point N, divides AB in the ratio of 1 to 2. So the ratio of AN to NB is 1 to 2. OM is A, so OM is A, and OB is B. Now I have to express ON in terms of A and B. So ON, so to go from point O to point N, so to go from this point to N, I have to go from O to M and from M to A and then from A to N. Now, since M is the midpoint of OA, so if OM is A, then MA is A for sure, because M is the midpoint, which means that M divides OA into 2 equal parts. So ON is equal to A plus AN, which is equal to 2A plus AN. Now how can I find AN? So first I have to find A B. So to find AB, I have first to go from point A to O, so AO, and then from O to B, so plus OB. Now AO is equal to negative 2A, and why negative here? Because OM is A and MA is A. So for OM, I'm going from O to M, and for MA, I'm going from M to A. However, here I'm going from A to O. So I'm going in the opposite direction. So it is negative A, which is equal to negative 2A, plus OB, which is B. Now, how can I find AN? Now, I'm given that the ratio of AN to NB is 1 to 2. So 1 to 2, and the total is 3. Now, the vector AB represents the total, so I'm going to write down AB under the total, so it's negative 2A plus B. And here I have AN because I want to find AN. So I will cross multiply. So 3AN is equal to negative 2A plus B. So AN is equal to negative 2A plus B over 3. So back to ON. So ON is equal to 2A plus AN. So it's 2A plus minus 2A plus B over 3. Now 2A, so plus minus means minus. So this is minus. So 2A minus 2A over 3 is 4A over 3, and I will add the B, so it's B over 3. So the final answer is 4A plus B over 3.